There are a lot of tutorials on YouTube and otherwise that teach you how to write thread safe code and prevent race condition, meaning how to implement parallelism without by synchronizing all the threads you're running, and how to use mutex locks. I wanted to try the opposite. What if we introduce a race condition and monitor the CPU usage while all the threads rush to perform an update? So what I've written is an increment function where you update this counter variable. So this is not an atomic operation, it is a read and write rolled into one. So all the threads are racing to update this particular counter, and we are monitoring the CPU usage at that time. So I have created 25 threads, and all of them are rushing to update this particular counter to 100,000. So the value should be 25 into 100,000. Now, since this operation is very fast and it will end very quickly, I've introduced a heavy computation, a square root calculation in between, so that we actually see the CPU utilization progress. So we are monitoring using the psutil library, and it prints the data and it checks every 4 seconds and prints the usage for every core. Now, so this monitor thread is created after the worker threads are created, and it is a daemon thread, meaning it will end as soon as the code exits. So side you can see the output of the code. So I have set the daemon thread to print the CPU usage, and it is checked every 5 seconds. So, and meanwhile I have set the square root calculation to 100, so it should be a very simple operation. Now if we run the code, we see that the operation gets over pretty quickly, and CPU usage is printed only once, meaning the entire operation gets over in less than 10 seconds, and the final value is as expected, which is 25 into 100,000. Now this is a very straightforward operation, so the effects of race condition are not visible, but we can still see that this particular update is not thread safe. Now if I increase this value, and this will slow down the increments done on the counter variable. So we see the CPU usage more often, and we get a idea of how it increases and decreases. So now that this function is has become slightly resource heavy, we see the CPU usage being printed more often. So at one point the CPU usage increases and then it starts decreasing again. So even then this is not a resource heavy operation. So in cases where there are multiple operations being performed, the CPU usage increase and decrease will be very visible. This video we have seen what is a very simple example of race condition and how to use the psutil library to monitor CPU usage when you use threads to support parallelism.